Okay, welcome back to section 7.8, which we call it improper integrals. Improper integrals are type of definite integral, something from a to b, f of x dx, but it has two types. Type 1, which we will call it infinite interval. What do we mean by infinite interval? It is a definite integral from a to b with something like this, which infinity is one of the limits. And sometimes it's the worst case where we have infinity in both sides. If we see something like this, where we have infinity or minus infinity, we call it improper integral of type 1, which is infinite interval. Such an integral will have two answers. Maybe if we find the answer, maybe we will get a real number, or maybe we'll get infinity, because you can see that there's an infinity, there's a possibility we get negative infinity, or maybe we get something like does not exist, infinity minus infinity, or something we can't find. In the first case, we will call it converges. In the second case, we call it diverges. Okay. So just to sum up everything, improper integral has two types. Type 1, which has infinity or minus infinity, and we have two options for the answer, real number or infinity minus infinity or does not exist, which means converges or diverges. Now, how we will deal with such an integral, we will see it in example 1 in the next video. Type 2 is something maybe usual to you, but look at this. You can see that 1 over x is not defined at 0. But I'm doing the integral up to 0. 1 over x is not defined at x equal to 0, but I'm doing the integral up to x equal to 0. So here we have to do something, and this is, we call it improper integral. And again, even improper integral of type 2, where we have unbounded function, we have two options for the answer, converges or diverges, depends on what we will get. Now, how we find, or how we evaluate, or how we determine converges or diverges, this will be in the next videos and the next examples.